Hey guys, and welcome to another exciting edition of Geometry Concepts and Skills. Today we're going to be looking at my good friend here, the trapezoid. So, trapezoid, hey? It's going to be something new that we've looked at. Obviously, this is a new lesson. We're going to be learning some new things. But what I mean by that is it's going to be different than the other little quadrilaterals we've been looking at. The trapezoid is a quadrilateral with exactly one pair of parallel sides. Those are all extremely important. Well, why might you ask? Because what it's saying is that this particular figure we're going to be looking at is not a parallelogram. So when we looked at rhombuses, we looked at squares, and we looked at rectangles, those particular shapes do not apply to what you have here for a trapezoid. Now, there's some interesting things here about a trapezoid we need to take a look at. First, it's the bases. What are the bases? Those are going to be the two parallel sides. So for the case of this figure right here, AB and DC are those two parallel sides. But that's it. You only have one. As you can clearly see, AD here and BC here are not going to be parallel with each other. These two figures, this AD and this BC, are actually known as the legs, and they are the non-parallel sides. Now, the legs also have something special with them as well too, and it's angles. If we take a look here, you see in green, I'll even more boldly highlight that in green, is with these angles right here, these are same side interior angles, or they're adding up to 180 degrees. So what that tells me here is this. If I were to add up this angle here of X and add up this angle here of Y, if I were to add those guys up, they would be 180 degrees. I can say the exact same thing there for BC. This angle here and this angle here, if I were to add them together, will equal 180 degrees. It's an extremely important thing for us to kind of take a look at and what we're going to be dealing with today. Now, let's continue to move on. We're now here at this spot, and this is just a little bit more reinforcement for those particular base angles that we were looking at. These guys here, as you can take a look, A and D right there, those angles, they're going to add up to 180 degrees. If I were to add 105 and 75, I'd get 180. Same thing here with the two angles for B and angle C. If I were to add these two guys up together, they're equaling 180 degrees as well. But if we take a look as well, the two top angles, what about those consecutive angles? As you can see, if I were to add any one of those two together, here, that's going to be way more than 180 degrees, while these two, if I add those together, are going to be way less. So again, this concept of 180 degrees, these supplementary angles are only working with those same side interior angles. Same thing can be said to the other figure to the right as well. We have these being our parallel lines, and these two angles then also be adding up to 180, and these as well too. Don't try to get too confused for these particular side or these trapezoids flipped around. They still mean that they have the same exact properties, because these are going to be the bases, and these are going to be those same side interior angles that we're looking at. Now, the main trapezoid we're going to be looking at is the isosceles trapezoid, or it's a trapezoid with congruent legs and plus congruent base angles. So what this is saying here is that these two sides are going to be the same with an isosceles trapezoid. And then when you look at the angles, take a look at what you have here. This angle, this top angle, and this other top angle, they're congruent. Just like how the bottom two angles there are going to be congruent as well. These are still adding up to 180 degrees though, so do take mind of that. Now, let's take a look at a few problems we're going to be dealing with. Here's the first one. I know on your sheet it looks a little bit different. So why don't you take a second here and pause the video and kind of redraw what you see with this figure right here. I know there was an old thing on top of it. Looked like it was just some kind of typo when it got printed out. So take a second and redraw that figure. Put this on pause and then come back. Okay, now you're back. Let's take a look at what we have here for these two. This is, again, an isosceles trapezoid. So these two sides are congruent, which also means that you're going to have some congruent angles. A and B are going to be congruent to each other, but it also means that this angle D and this angle C are going to be congruent as well. Well, what happens when two things are congruent? Well, we're going to set them equal to each other. So this is going to be then 6x plus 8 equals 74. Subtract 8 from 74, give you 6x equals 66, and then we divide by 6, x is going to equal 11 right there. Let's take a look now at the next one. The next one is going to be kind of one thing that I really focused on in the beginning, and that is these two angles right there. What do we know about those in respect to a trapezoid? Well, remember, they're same side interior angles, so we're going to add them together and set it equal to 180 degrees. Remember, we can only do that with those two angles or these two. Can't do that with AB and DC, meaning these two angles right there. So again, we're going to take 3x plus 25, set that add that with the 110 and set that equal to 180 this time. So this is then giving us 3x plus 135 equals 180. We're going to subtract that 135, subtract that 135, and now you've got 3x equals 45, where when we divide by 3, x equals 15. Now, I want you to give them the next one a try on your own. Be careful, though. Take a look at what are the things that are congruent. This is an isosceles trapezoid. So if those two sides are the same, what are you going to do? The next question you need to ask yourself is, what do you need to do with this 3x plus 4, if anything? Try that out. We'll take a look at that then tomorrow. Last thing we're going to be taking a look at is something called a median. The median is a segment that connects the midpoints of the legs of a trapezoid. This is also known as the mid-segment. This is going to have a little formula attached to it, and it's just the median equals 1/2 of base 1 plus base 2. In other words, it's going to be kind of like the average. So here's your first base, here's your second base, and in blue here we'll highlight this dude as being the median. Let's take a look at what we have here. So let's say that we're given 10 here, and we're given this 20 here. How do you figure out that this x is 15? Well, again, let's take a look at this. 1/2 of the base 1. Well, what was base 1? It was 10. Plus the base 2, which is 20. Add 10 and 20 together, you're going to get 30. So then 1/2 times 30. And then what is 1/2 of 30? 15. And lo and behold, you have that right there. Another way you can take a look at this is if you know that this guy here is 15, what is the difference? They both have to have a separated difference from each other. So from 15 to 20, plus 5 as you can see, while this 15 to 10 is -5. All right, let's take a look at the second one. Let's say we know the middle guy and we know the top one, or this bottom one, sorry. So we know that this middle guy here, that's 22. We know that the base 2, or the bottom one, is 30. How are we then going to figure out what x is right here? Well, it's going to be taking a look at what is the difference between the two. From the mid guy to the very end, it's a difference or an addition of 8, which then means if I was to go backwards to get x, let's just say, I'm going to subtract it by the exact same amount. And that's where you're getting this x equals 14. Pretty simple stuff. All right, take a look at that one problem that we looked at. Be ready to go for tomorrow, and we'll be talking to you guys soon. Thank you very much. Bye-bye.